The following example shows three modules for bakery stuff, the functions they perform while baking, and the bakery itself. We see how functionality that is exported by one module is imported and used by the other. So here, file name stop.mjs specify public exports that can be consumed by other modules. Here, the file name cakefactory.mjs imported that export const baker. So import baker from slash modules slash stop.mjs and then export an oven. And then the file name bakery.mjs import the cake factory from modules slash cakefactory.mjs. So these const oven are actually typo. So we will explain why that is. First, the code as written is wrong. Look carefully. In cakefactory.mjs, export const oven, etc. This exports oven, but in bakery.mjs, we import the cake factory. There is no cake factory export in that file, so this import is invalid. It should be either import oven or the file should actually export something called cake factory. So the example is inconsistent. That's the first issue. What it probably intended to show, most likely the author meant something like this: cakefactory.mjs, import baker from /stop.mjs, then export const cakefactory equal oven, or inside this oven object, and then inside oven object we have make cupcake function, and then make muffin size. Then in bakery.mjs, we import cake factory from /cakefactory.mjs, then cakefactory.oven.make cupcake argument sprinkles, and then make factory.oven.make muffin argument large. Now it makes sense. Now your real question, why import cake factory instead of oven directly? This is an architectural boundary question, and this connects directly to everything we discussed about the decoupling and patterns. Option 1, import oven directly. Import oven from /cakefactory.mjs, then oven.make cupcake argument sprinkles. This means bakery depends directly on oven. Tight coupling. If tomorrow the factory changes structure, bakery breaks. Option 2, import factory abstraction layer. Import cake factory from /cakefactory.mjs, next line cakefactory.oven.make cupcake argument sprinkles. Now, bakery depends on factory, not on oven. Factory becomes a facade. If later oven changes, multiple ovens are added, baking becomes a sink, logic moves elsewhere. Bakery doesn't change. This is architectural decoupling. This is the same principle as React. Instead of chat panel.open, you do dispatch argument message colon open underscore chat. You depend on abstraction, not implementation. Why this matters in modules? Modules define what is internal, private, what is public, exported API. If cake factory export only, like export const cake factory equal open semi-curly bracket closing semi-curly bracket, then everything inside is hidden behind that API. This is the module pattern in modern ES modules. Big picture connection. This example is demonstrating module pattern. Each file is its own scope. Second, dependency and declaration. Import makes dependencies explicit. Third, decoupling. Bakery does not know about baker directly. It only knows about factory. Fourth, abstraction layer. Factory shields implementation details. Now the deeper system level insight. If bakery imported baker directly, import baker from /stuff.mjs, then bakery becomes tightly coupled to stuff. That's like React components directly mutating global state, but bad architecture. Instead, bakery to factory to oven to baker. Layered responsibility. Same structure as UI to controller to dispatcher to store to state. Why this confuse you? Because the example mixes incorrect export naming, slightly inconsistent module structure, so it feels wrong. But the intended lesson is export higher level abstraction, not low level implementation details. Real world analogy: Baker is the customer interface, Cake Factory is the service layer, Oven and Baker are internal workers. Customers don't talk to ovens directly, they talk to the bakery system. That's architecture. Final clean version corrected stuff.mjs. Export const baker equal open semicolon inside bake argument item. Then inside open curly update console.log. Woo, I just baked dollar. Inside is open and close. Inside this open and close is the item variable. Then closing, and then cake factory.mjs this, and then bakery.mjs is here. So we just refactored or changed that code. Cleaner, better abstraction. The big lesson: this example is not about baking, it's about module boundaries, abstraction layers, decoupling, exporting interfaces, not internals, which is the same philosophy behind React, Redux, command pattern, mediator pattern, your live kit controller. You're now thinking at the system boundary level. Typically, a module file system contains several related functions, constants, and variables. So a module has the related functions, constants, and variables. So that's actually what a module is. It's the relationship between those functions, variable, and constant. You can collectively export this at the end of the file using a single export statement followed by a comma-separated list of the module resources you want to export. So like here, we have defined three const object with the function inside it, and then we export that with a comma separated. Export baker, comma pastry chef, comma assistant. Similarly, you can import only the functions you need. Like here, import baker, comma assistant from /module/top.mjs. You can tell browsers to accept script tags that contains JavaScript modules by specifying the type attribute with the value of module, such as here, script type equal module, then src equal main.mjs, and then closing script. Another is script no module src equal fallback.js closing script. So what does no module mean? The no module attribute tells modern browsers not to load classic script as a module, because previous browsers do not support the modules yet. Therefore, in order for you or for them to not load that as a module, to avoid that unintended consequences, you would write this no module. So step 1, there are two script models in browsers. Browsers historically only support classic scripts such as script src equal app.js closing script. These share global scope, don't support import/export, execute immediately, load synchronously, blocking by default. Then ES modules were added. Modern way: script type module src equal main.mjs, then closing script. These support import/export, have their own scope, are deferred automatically. Load dependencies in a module graph. So now there are two script types. Type classic script, supports import or export, no. Scope global. Era old. Type module script, supports import or export, yes. Scope era modern. Module objects. A cleaner approach to importing and using module resources is to import the module as an object. This makes all the export available as members of the object. So if we import, such as here, import asterisk as stuff from /module/top.mjs, it means that we import that, all of the file on that module. That's what we mean by importing the module as an object. So here we can now use anything inside the stuff.mjs. So now we can use that to export our function or an object. Export const oven equal make up cake function, the argument stopping, and then stuff.baker.bake. So we just use some function or method from stuff.mjs and then make pastry argument msize, etc. So what import asterisk as stuff actually means? It means import everything that this module exports and bundle it into an object called stuff. So if stuff.mjs contains export const baker equal dot and export const pastry chef, those exports will be available in that file. Then import asterisk as stuff from ./stuff.mjs is roughly equivalent to const stuff equal inside is a baker, exported baker, and a pastry chef. Stuff becomes a module namespace object, not a class, not a constructor, not magic, just an object containing all exports. Why suddenly use stuff? Earlier examples likely use import baker from ./stuff.mjs. That is called name export. It pulls only one export, but import asterisk as stuff from ./stuff.mjs is a namespace import. It pulls all exports under one object. So instead of baker.bake and then pastrychef.make, you write stuff.baker.bake, stuff.pastrychef.make. Same functionality, different import style. So if you have that type of import, to be able to use the function inside it, you would need a different namespacing like this. So you would need to use stuff first before you would use the method. But they have the same value that you import from other method. Why would someone do this? 3 main reasons: namespacing / isolation. If you import everything directly, import baker, pastry chef from ./stuff.mjs, those names enter your local space. If you have another baker variable, collision. But import asterisk as stuff, now everything lives under stuff, cleaner boundary. It also means like you separate the names. As you can see, those now have different name because you just added stuff before the name. So clear ownership, that's another reason. When you see stuff.baker.bake, you instantly know this comes from the stuff module. That's explicit isolation. Third, organizational pattern. It mimics math.random function, date.now function, console.log, namespacing, grouping. So let's just continue with 4, 5, 6 in the next video.